Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 3, Section 2, Part 3. So previously on Part 2, we talked about specific heat being the quantity of energy it takes per gram of a certain substance to raise the temperature by 1 degree Celsius. And we talked about how water has a high specific heat because of hydrogen bonding, and how specific heat, like density and boiling point and melting point, is a characteristic property. It does not depend on how much of that material you have. It only depends on the substance. And we jumped into the heat equation, which is heat measured in joules is equal to the mass measured in grams times this quantity called specific heat, which we know is a characteristic property measured in joules per gram degree Celsius, times our change in temperature measured in Celsius. Well, that's a lot to write, so let's write the equation using variables. Q stands for heat, I don't know why, equals mCp. Cp stands for specific heat, again, I don't know why, it just does, and then delta means change in. Well, the computer was being a little bit ornery, so let's try this on the smartboard. So we know, let's figure out what we know first. We know the mass is 100 grams. We know our change in temperature goes from 20 to 2000, which they don't want either of those, they want the change. So 2000 minus 20 is 1980 joules, which I can scroll down on this, so I might as well just write it there. Okay, and then what are we looking for? We're looking for how much heat, which is Q, and that is our variable. But wait a minute, we still have Cp to go into the equation. We have two variables, we can't do it? Give up and go home? No! All we need to know is the specific heat, which we know is always the same, and we know that we have steel, so we just need to figure out the specific heat of steel, which is found in your book. On page 83, table 3.1, it tells us that steel has a specific heat of 0.470 joules per gram degrees Celsius. So once we find out what we know and what we need to know, our next step is to write the equation. So we write Q equals mCp delta T. And I sub in my numbers. Q is my variable. Mass is 100 grams times our specific heat, which is 0.470 joules per gram degrees Celsius, times our change in temperature, which is 1980 degrees Celsius. So I rewrite my equation and my equal sign, my variable and my equal sign. Now I can grab my calculator. 100 times 0.470 times 1980 is 93,060. Today we are going to look at our variables. This grams cancels with this grams, and this degree Celsius cancels with that degree Celsius, and we're left with joules. And today we are not going to worry about sig figs, because it would technically only have one, which would be 90,000, but we're just not going to worry about it right today. So the question is, did we answer the question? How much heat? Well, heat is measured in joules, and our answer has joules, so we set it up correctly and we answered the question. The second thing is, does it make sense? So if your specific heat is 0.470, that's about half a joule of energy per gram degree Celsius, but we don't have 1 gram, we have 100 grams, so that would be about 50 joules for every degree Celsius. And so we take 50 times 1980, and we get 99,000 joules. Is our answer in the ballpark of 99,000 joules? It is. We got a reasonable answer and we answered the question. Good job. So you can see not only did we answer the question, but we also got the answer that the book got. Okay, now we're going to up our game with solving problems with the first law of thermodynamics. So what we need to know with that first law of thermodynamics is that energy is always conserved. So please write all this down. The heat flow out of a system is going to equal the heat flow by the surroundings. And let's just jump into it. So, second example, a mass of 300 grams of water at 80 degrees Celsius cools down to 20 degrees Celsius. Assume all of the heat from the water is absorbed by 100 cubic meters of air, which is a small room, with a mass of 100,000 grams. What is the temperature change in the air? So please write that down. Okay, so we're going to figure out what we know. So we know that 300 grams of water, so our mass of water equals 300 grams. And then we know it goes from 80 degrees, actually I'm just going to stay with blue. And we know it goes from 80 degrees to 20 degrees. So our change of temperature of our water is 80 to 20, 60 degrees Celsius. And then we also know that, so do we need to know it's 100 cubic meters of air? No, we just need to know the mass of the air. So the mass of the air, and you're like, wait a minute, I already have a mass. So we're thinking about, we have two different substances. So when we have two different substances, let's just stop and pause and try and figure out where we're at. So it says, what is the temperature change in the air? But it gave us the temperature change of the water and the mass of the water. You're like, how could I even do this? Give up and go home? No. If you remember, we just talked about the law of conservation of energy. Whatever energy is lost by one system has to be gained by another. So we have two systems. We have the water system and the air system. So we're going to have to solve it for each system. All right, so let's come over here, and our mass of our air is 100,000 grams. And then what else do we know? Well, our change in temperature of the air is what we're trying to figure out. Delta T. And then, so we know Q. Well, we're going to have to figure out Q in both of them. And so there's Q, there's mass. We have mass of both. There's CP, which isn't in either of these. But can I figure out? Let's try it. Table 3.1 in your book on page 83 has both air and water. So our CP of water equals 4.184 joules per gram degrees Celsius. And our CP of air equals 1.006 joules per gram degrees Celsius. Okay, so now we have what we need. We know that we have more numbers in the water, blue category, than we do in the air, so that would be a good place to start. So we know our overall plan is that the energy lost by the water, because it's cooling down, is going to be equal to the energy gained by the air. So I will kind of split screen for a little bit and then come back together. So Q equals mCp delta T. And we know Q equals mass, which is 300 grams, times CP, which is 4.184 joules per gram degrees Celsius, times our change in temperature, which is 60 degrees Celsius. And then I bring my variable and my equal sign down again, and now I can grab out my calculator. And I say 300 times 4.184 times 60 equals 75,312. 75,312. And again, our grams canceled and our degrees Celsius canceled, and we're left with joules. So the water lost 75,312 joules. So we know that whatever the water lost, the air is going to gain. So just to repeat that, Q lost equals energy gained by the air. And we know that our Q lost is 75,312. So I'm just going to write, let me see how I want to do this. Let's write the equation down. So Q equals mCp delta T. And we know that this 75,312 is going to be the same as the Q for the air. So we write 75,312 joules equals mass, which we wrote up here as 100,000 grams, 100,000 grams, times Cp, which we figured out was 1.006 joules per gram degrees Celsius, times our change in temperature, which is what we're trying to figure out. All right, so let's bring our numbers down and simplify that, and what you can probably do in your head without a calculator. So 75,312 joules equals, well, it's 1, 2, 3, 4, 5, 6, 5 decimal places. So 1, 2, 3, 4, 5. 1,006 plus 5. Okay, let's double check. It went 1, 2, 3, 4, 5. So that'd be 100,600. And then the grams and grams, we would still have joules per degree Celsius times delta T. Whew. So now I have a variable, and so I want to get that variable by itself. So I divide by 100,600 joules per degree Celsius, and whatever I do on one side, I have to do on the other. 100,600 joules per degree Celsius. Okay, these cancel out, and on the right side, I'm left with delta T. And then on the left side, I'm going to have to grab out my calculator. And when I divide 75,312 divided by 100,600, I get 0.7486 joules, and joules canceled. I'm left with 1 over degrees Celsius, and when you're dividing by a reciprocal, it's same as having the its reciprocal, so the degree Celsius actually goes to just being on the top. All right, so let's see. Did we answer the question? All the way back up here. What is the temperature in the air? So, what is the temperature change in the air? Well, we got a temperature change. And again, I'm going to skip sig figs for a little bit because this would all be 1, and I'm probably going to round it to the nearest hundredth. And let's see, if a beaker of water, 300 grams, cools down 60 degrees, is it going to heat a room up very much? No. And indeed, it heated it up less than 1 degree. So 0.57 degrees Celsius is our change in temperature of the air. That makes sense. All right, good job. Okay, we're running out of time here, so I'm going to make one last short video on heat transfer. I will see you then. Bye.